Three, two, one, and we are live. Hello, everyone. Welcome to the 345 Tech Talks podcast. And in this episode, we are talking about our DevOps stack. So last two episodes, we've talked about the 10 principles of DevOps, which are the underpinnings of DevOps. And what we're going to talk about today is actually making that stack hit the road, make that actually work. So just recapping for everyone that has been living in a cave for the last couple of months and hasn't heard us talk about this. I mean, the first thing is that what we're talking about today, especially, is the stack that underpins the DevOps for Glue, which is our venture, and Glue is TripAdvisor for cryptocurrencies. It's the place where you go to discover the world of cryptocurrencies. Launching Q2 this year. It's an exciting and amazing project in its own right, but technically there's a lot of good stuff come out of it, which we are talking about in the podcast series. As 345, we concentrate on 7 outcomes for success, and the 7 outcomes are rapid delivery, quality and bug-free, available and scalable, secure, functional, lovable, cost optimized, and standards compliant. And when we talk about DevOps, then really rapid delivery is an important one, because if we can automate the process of software delivery, we can start to deliver more rapidly. Quality and bug-free is another one, that through automation and automate testing, that we have repeatable quality processes which make sure that we could do our best to make sure that our systems are delivered with quality. DevOps helps us make more secure systems because we don't need to have manual intervention. So the less manual intervention we can have, the less we can worry about elevation of privilege and malicious usage of our software. So security is an important thing, and really costs. The more we can automate and the more we reduce the toil of developing software, then we optimize our costs. So those are the sort of things that we're talking about when we're talking about DevOps. We get loads and loads of good things out of DevOps, which is why it's a big topic in the world. And as we learned last week or the week before, that DevOps is like gardening. In that it's sort of it takes you ages to put the groundwork in, and then when everyone sees it and thinks it's marvelous, they don't realize just how much effort you've had to put in to get it to do that.
Exactly that. Well, I like building a house, right? It's all those foundations.
Yeah,
Take time. They cost money.
And but the other way I look at it,
right, to the quality of the building.
Yeah, or the other way I look at it is that it's like, and I think that we mentioned this one. It's if you're building cars, you don't just build cars. The first thing you have to do is to build a factory. And once you've built the factory, you can get high quality cars coming off a production line. And it's a similar thing with software, that you're building a production line, and then we can get our apps, microservices coming off that with speed and with quality. And so, in that vein, what we're talking about today really is, okay, we'll build our software factory. Well, what actually are the things that we're building that factory with? So that's what we're going to talk about today. Is that, what's the stack, and some of the some of the key reasons those have been chosen, or the good things, or the notable things about it. So the obvious place to start really is where everything lives, which is source control.
Yeah. So naturally it's a Git based source control system.
Does anyone in the world not use Git?
Probably not anymore. I would say. Maybe there are still a few people working on
got a few zips on a file share somewhere.
Yeah, exactly. Yeah. So many years ago, used Visual Source Safe, right? So
or Visual Source Mangler, as it was known.
Things have moved on. Yeah, I'd say pretty much Git is the gold standard now, isn't it, for source control?
It is, but it's like
So
but there are many flavors,
there are many flavors.
and
So the
we've
Git
chosen.
itself is wonderful, but obviously we use a hosted Git service, um, mainly because it's cheaper to let somebody else manage the service for us. So I think it'd be no surprise to anyone that we're using GitHub. I mean, there are others, and we
Yeah,
have used others before. So I actually, we spent quite a bit of time working on or using Visual Studio Team Services, which is now not called that. Azure DevOps, I think now something, but it's been a while since I've looked at it. But I mean, VSTS, as I still call it, is actually a great product. There's nothing wrong with it. It's really good.
yeah.
So
And we looked at Bitbucket as well.
we looked at Bitbucket. Didn't spend too much time on Bitbucket. Just a little bit disappointed with Bitbucket, to be honest.
I think so the reason why we were disappointed with Bitbucket is, I mean, Bitbucket is made to be part of the Atlassian suite,
Yeah,
and if it's like, okay, Bitbucket on its own, it's just like, oh, it's Git, but you kind of have to swallow the whole suite for it to kind of make sense. Whereas the thing that's good about GitHub is that it kind of plays nicely with so many other things. That
it's a very open,
it's that
very
open ecosystem, isn't it?
ecosystem around GitHub. That's really hard to ignore, to be honest.
And it's a bit like when you buy, if you buy an iPhone, or when iPhones came out, the thing that was compelling about it was the app ecosystem that was on it. I mean, that's this Android's obviously a comparable ecosystem now, but that's where all the other flavors of phone died because they couldn't have the app ecosystem, and it's that app ecosystem around GitHub that is so good.
It is, and a lot of quality extensions and integrations that you can get. It's if you can't do it with GitHub, then you probably can't do it at all. So, but yeah, we trialed Bitbucket and we used the full suite. So we used Jira for task management, and just the whole thing just didn't really gel well together. Which is surprising given that the
But it's the
product.
same manufacturer. Yeah.
Yeah, exactly. In fact, actually, what we ended up doing was unhooking Bitbucket and using GitHub. And actually, at the time, the integration was better between Jira and GitHub than it was between Jira and Bitbucket. It was just totally bizarre. So yeah, so we sort of, I mean, not saying that people, there are obviously a lot of people that use the Atlassian suite and get on with it, but it didn't really fit with us. So yeah, but I mean, in terms of GitHub, also another good reason for using GitHub is if you have any open source repositories, then pretty much you would say most of them are accessible through GitHub. They're on GitHub. I know that there was it sort of. I thought it was a bit bizarre, but obviously when Microsoft bought GitHub, there were groups of people who were obviously unhappy with it, given that it was Microsoft. Why, I don't know, but and made a point of moving their repositories out of GitHub onto GitLab, which I just find stuff like that so bizarre. But I would say most open source repositories are probably still on GitHub.
So
So if we've got a combined, so some of our repositories being open source and some being closed source, it doesn't make sense to have your closed source repositories in a completely different hosted service to your open source repositories. You might as well just use one.
Same set of tooling, all that sort of thing. I mean, this interesting thing though, I mean, just as a little diversion, with the whole thing with Microsoft. I mean, I think in the 90s, probably early 2000s, Microsoft definitely rubbed themselves the wrong way, or upset a lot of people who were wanting to pursue open source. And I wonder whether, shall we say, if you were a software dev that's really just learnt your trade in the last 5 years, would you still hate Microsoft in the way that the, shall we say, the more sandal wearing amongst the software community, that certainly from 10, 15 years ago hate Microsoft? Or, because you look at, Apple really are just as, they're just as commercially tight as Microsoft, and Microsoft have tried to be a bit more friendly, and then, who else have you got? I mean, you look at all the other big vendors, and you could make an argument against all of them, really. So I don't know. It's an interesting question.
It is, and it is definitely a can of worms, and there's a lot of emotion on
Yeah,
both sides. At the end of the day, I think we've always said, right tool for the right job, right? So, and our stack is, we've said before, we're using Kubernetes. That's running on Linux containers. And it makes sense for us to choose a tech stack that actually fits into that area. And so whilst and I've got many years of experience working on the Microsoft platform, as I have on IBM mainframes, on Unix, and more recently on Linux and so on. Actually, it's just what's the best tool for the job. They've all got the pros and cons. So what's the best tool? And at the moment for us, it's the Linux world.
So that's we're probably getting a little bit ahead of ourselves there.
We probably
We'll
are.
talk, we'll talk a lot. We'll talk a lot about that. But okay. So we've got GitHub. GitHub plays nicely with things. So the first thing is if in a DevOps workflow you checked, you've made some commit. The first thing you want to do then is to trigger your CI service. So we use Shippable for that. So what is it about Shippable that we really like, apart from the fact that their logo is a cute little mouse?
It's not for the logo. So Shippable is actually relatively easy service to use. It's container based, which is another really good thing. So the builds are running containers. Interestingly, we also run our own builds within our own containers as well, but on the Shippable container-based build.
Yeah, so the fact that they containerize the build, so in Shippable you can choose your container, but you can give them the container that you can give them your own container.
Yes, absolutely. Yes, of course you can do that. We don't. We actually, so we do use one of their containers, obviously, but we don't tell them what container to use. So they just use a standard Ubuntu container. But then when the CI build is kicked off on Shippable, we then run our own DevOps container to then run our so we use something called pipeline, which we get onto in a minute. But so we basically run a pipeline runner inside our own DevOps container, which then does all of our quality checks and run tests and all that sort of good stuff. So although we use Shippable as a hosted CI service is container based, but we also then run our own DevOps container inside that environment. But one thing that Shippable does do, that hosted CI services that integrate with GitHub, is that integration with GitHub is really good. So it integrates back into, so when you're inside like a pull request, and then you approve the pull request, and then you've got certain checks that you need to pass before you can merge the change into the master. All of that integration is in through Shippable, and it's all out of the box.
Yeah. So effectively, it's whether your build is showing it's green or showing it's red. All that sort of stuff is almost like you get that for free.
Exactly, and test coverage, whether tests have passed or failed, all affect the status of the build, and therefore whether that pull request has succeeded or not.
Yeah. And actually, going back to GitHub, I mean, that the sort of stuff you can do to protect the quality of your branches, actually all that stuff works really well. So you can have protected branches, and to merge into a protected branch, you have to have a clean CI build.
Yeah.
So actually, the two of those together, so GitHub for all the source, and using Shippable as a CI and protecting the quality of the code on the branches.
Yeah. So literally as a hosting environment to run our DevOps containers, in effect, that's what we use Shippable for. And we're pretty lightweight with it. I mean, in theory, we could take our DevOps containers and run them somewhere else. We just need the hosting environment in order to be able to kick those containers off. But as I say, the one thing that let's say, for example, we've explored this idea. Let's say we wanted to run our DevOps container in AWS Fargate, which is like a container as a service type environment where you pay for the running of the container. And so when the container stops, like a DevOps build process is like a finite time for the execution of that container. So you pay for the amount of time that you execute in that container in Fargate. So we could use that. Actually, that will make quite a bit of sense. But what you lose is that integration with GitHub. So you'd have to build that integration to make sure that you can get things like code coverage and the build badges and all those sorts of things out of your custom solution now and integrated into GitHub.
And you know what? Someone's already done that, and life's too short.
Someone's already done that, and life's too short. It's I guess it depends on the cost becomes a factor, right? So if you want to be pretty lean with cost, then at some point there will be a tipping point that says, actually, you know what, the investment in making that integration work, given that we might end up with a really big DevOps infrastructure, it might make more sense to go down that route. But for the moment, it's a no-brainer. Why would you even consider building a custom solution when you can pay $50 a month for a hosted CI service?
Yeah, and there is I mean, let's face it. In all these things, typically, you look at the cost of what it costs you per day to get a technical guy to do stuff, and so and then you look at it like that, and you kind of think, well, for a couple of days, possibly I can run. You can just use Spinnaker for a year for a couple of days worth of someone's time, and you can have that tomorrow. There's a reason why we use all these things, and
exactly.
And it's the maintenance of it as well, because if you did it yourself, you'd have to maintain it, and then that's someone's time all the time for it. So one of the things that I suppose is why you might have gone to AWS is the whole thing of how you're flipping between environments then, because when we haven't really made a secret of the fact that we run quite a lot. We run everything Kubernetes, and that's in AWS. And so, having got our build in GitHub, you still got somehow once you've got a great build to say, okay, we've done our CI, our code is clean, let's push that through AWS. You've got that handover, haven't you? So, how do we? What's the sort of tooling for that?
So if we just all closed Shippable off for the moment, we could have used, Travis Circle CI is becoming quite popular. They're all much of a muchness.
Yeah.
So we'd had previous experience with Shippable. It made sense to continue to use Shippable. We're not really coming up against any things that we can't do with Shippable. It's cheap. Why not use it?
And it's got a friendly mouse.
And it's got a friendly mouse, which is the icon on the cake, right? So,
whereas Travis has got some annoying bloke as their icon.
Right, okay. I didn't know that, but yeah.
Obviously, I choose the deep reasons.
So within Shippable, when we run the build, it has different stages. And when we can hook into environment variables, just say, is this a master build? Is this like even if this is a release in GitHub, so you can trigger builds off releases, which is really good, and we do use that. You can trigger builds off tagging branches in GitHub. There's lots of different ways in which you can hook in to trigger various different things. So obviously we have PR builds.
Yeah.
We have a build off the master branch. And then when it is off the master branch, then we hook into that and say, right, okay, now we need to kick off our continuous delivery process.
Yeah.
Now, our CD service is we use Spinnaker, which is sort of come out of the Netflix stable as a way of managing deployment of services, microservices to an environment.
Yeah,
could be natively to a cloud environment, could be to a Kubernetes cluster, so deploying pods to a Kubernetes cluster and so on, and it can manage all of that. So, but the trigger point for us, certainly at the moment, is we use webhook. We just use a simple webhook to kick a pipeline off in Spinnaker from shippable. Now, there are some, so certainly there were in earlier versions of Spinnaker. I think it might be solved now, but ideally what we would do is at the end of the shippable process, what we do is we publish a container to our AWS ECR registry. And the publishing of that container, normally what would happen is Spinnaker could detect that and say, actually, I can kick a pipeline off. So that's the trigger for kicking a pipeline off in Spinnaker. But because it's an ECR repository, which is private and has, and you need AWS IAM permissions in order to access it. There wasn't a particularly easy way, out of the box to be able to hook that up in Spinnaker. And as I say, I believe that they've recently solved that now, but we haven't yet utilized it. So, these are all things that need to go on the backlog to be looked at. But in effect, at the moment, what we do is we just do a simple webhook, and we poke the pipeline to say, right, trigger. We have already published containers to the registry, and then we just, at the end of that, just hit the webhook. The pipeline's triggered, which can then pull down the containers into Spinnaker. And so Spinnaker for us, we actually run that inside AWS, so inside our environment. Runs in its own AWS account for isolation. So it's completely isolated from a resource perspective from other workloads, so test, stage, and production, all in their own AWS accounts. It's a good security.
But it's the same. It's the same Spinnaker instance managing the flow.
Yeah, so we have one Spinnaker instance managing all of the environments, so all of the deployments to all of the environments that we have. And the Spinnaker itself also runs on Kubernetes. So the Spinnaker deployment is all containerized. And so we actually we provision what we call a DevOps cluster in AWS, and then deployed Spinnaker on that cluster as a set of containers. So Spinnaker itself runs on Kubernetes. And so that's pretty much how we do it. So our sort of source control trigger to CI, trigger to CD. Source control triggered to CIs through the integration with shippable, and then at the end of the shippable build, in effect, we then trigger a webhook into Spinnaker. As simple as that.
And just I mean, some of the alternatives to Spinnaker, Jenkins springs to mind.
Jenkins,
it's probably the most popular one that people are using.
As I say, we mentioned VSTS, Dual DevOps now, I think. But so they have something called release management, which you can actually unhook their source control system, so you can have GitHub hooking directly into release management. Release management is really good. I've used that before. But Spinnaker is much more of a native. So the things that Spinnaker that give you that are really interesting are strategies for upgrading microservices in an environment. So having native support for doing things like blue, green, canary deployments and so on. And so that's a really, really interesting part of Spinnaker, which you won't necessarily get with a more general purpose, continuous delivery type service.
Yeah, that's all. Yeah, that's all great stuff, and it shows probably like you say, because spinach can't even use my mouth now.
Yeah.
Because Spinnaker has come from the Netflix stable, and we all know that Netflix do amazing stuff with their technology. That yeah, and it shows that it's being built on people that are doing that who have to roll out features without downtime, be available all the time, and it's and Netflix are just if I'll just say for the benefit of the listeners, if anyone hasn't been and read the stuff that Netflix put out about their technology, it's just mind blowing. Just go and read it because they're quite open about what they do because obviously their business isn't technology per se. Their business is providing content to people. So they're actually really really open about how they run their tech, and it's just mind blowing what they do. So
I mean, exactly. So there's a lot of companies out there that talk about how they do stuff, and what I find really interesting about that is just getting ideas, seeing how other people do things. It doesn't necessarily mean it translates one-to-one to your environment, right? But it gives you lots of really good ideas. You're not the only person doing these things.
And it's an important thing, and it's in terms of mindset and I talk quite a lot about mindset and how you should approach things because I think a lot of because we didn't introduce ourselves obviously, but here's Paul. Paul's CTO of Glue and also a co-owner of 345. I'm a co-owner of 345 and CEO of Glue. And 345 is a software services company. We provide great engineers to companies to augment their existing teams and help them deliver software faster and better. And the companies that struggle that we work with are the ones that are always trying to reinvent the wheel. And when you look at things like what Netflix put out, or and the stuff that LinkedIn have said about what they do with Kafka, and the stuff that Facebook have done with Cassandra and that sort of thing, and you look at I've got a problem. Has it been solved before? And what sort of things are people doing to solve that problem? And that's a really, really important thing. Look outside. Has someone solved this? Because if they've solved it, then as from the point of view of someone delivering software, you should think, how can I go and learn more about how this problem has already been solved, rather than I'm going to solve it myself, which is fun, but it's not. but it's not necessarily the best way of going about it.
No, exactly. And what would we do without Stack Overflow or blogs, or just simply being able to Google search something, right? So what would we do without that these days, given the fact that software's got so much more complex than it used to be? I mean, back in the day, you had your Kernighan and Ritchie, right? Your C book, that was your Bible. If you were programming. Go back to the mainframe days. You had tons and tons and tons of manuals, but there was no other place you could go to get the information. You had to find it in a manual. So these days we're quite spoiled.
So I think what you're saying is, kids, if you're listening,
you don't know.
Paul was programming before the internet existed.
Oh dear. Was it 30 years? What was it? 30 years this week? Was it this week or soon or
something like that?
The internet or the web? Sorry, not the internet. So actually, that's true. Just
Whereas my first kind of proper job doing software was 2000. So I think Google had just about existed by that point, so you could Google stuff. So I've never done a software. I mean, because before that I used to do I used to do kind of an engineering role where I wrote programs as part of what I was doing, but not that wasn't my job. And then I decided I'd just go and do software. And yeah, so I've never done a software role where Google didn't exist. But way off topic. But the thing is, don't reinvent the wheel. Don't reinvent the wheel because you're not doing,
Chances are you're probably doing something somebody else
yeah,
has
and
already done.
and have the humility to acknowledge that the other person that's done it is probably cleverer and more experienced and might have done it better.
Yeah.
And that what you need to do is to solve the problem of your own business. How can you differentiate your business, not how can you solve a technical problem that someone else already solved. It's what is it that makes your organization, your business unique, and focus on that. Don't focus on reinventing stuff, which I think was where we got to with Spinnaker. So like, I think we got a bit off beam there. What bit do you want to pick up next?
So I think it's worth probably talking about Piper.
Yep.
We actually really should do a session on this with Thomas, who's another
Yep.
co-owner of 345, because so he wrote this. This is effectively his open source project, and we use it as in summary, it is a very simple step runner. So you create pipelines in YAML, and the pipelines in YAML are simply a bunch of steps that it executes one after another after another. And there's no sort of branching, and there's no complex flow logic, but there are some neat little features that allow you to do things like swallow errors or skip steps and so on. But in effect, it's a basic step runner. And the reason we use it is because through a DevOps process, there are sort of
it's very pipeliney, isn't it?
Very pipeliney, and there are big steps that happen. But within those big steps, there's lots of little small things that sort of go on. So, for example, if we are, say, running some quality checks on a software change, so we need to compile the new program, and then we want to run some unit tests, and then maybe we want to do some static code analysis, and then we want to get code coverage results out, and all those sorts of things. We want to make the test results available to shippable and so on. So what you find is that the sort of like the big step is like do quality checks, okay? But within that, there's a lot of small steps that need to happen. Now, you could write a shell script to do that, but then when you write a shell script, you've got to consider what happens if steps go wrong. So you've got to put in exception handling, got to make it robust, and so on. Whereas the nice thing about what Piper gives us is the ability to be able to just focus on the steps and let the Piper itself, the pipeline runner, deal with all of the stuff that you would naturally have to put into a shell script and so on. And because we use that everywhere to run these small little groups of steps that do certain things within the DevOps process. And what it does is it makes the whole end-to-end DevOps process quite consistent, because in effect it's large steps punctuated by Piper pipelines, which then kick off another large step, which then do some more pipelines. So you can think of it as like the glue between steps. And it's from that perspective, it's like really, really good. So we use it for quite a bit more than just doing simple quality checks. So, if you're setting up infrastructure, so you're running Terraform. When you're running Terraform, chances are you're probably doing quite a bit more around that. So you might be trying to set up your AWS environment. It's in terms of like the credentials. So you're setting up an active session and so on. So all of these small steps that need to occur, we actually just code them up in a YAML pipeline as a series of steps run by Piper.
And I think that's one of the key things to note about Piper is that it is YAML based. So effectively, you're describing your pipeline in a human readable way, and then the Piper runner will then just go and kind of do that stuff for you.
Exactly. So if you're thinking about, say, let's take infrastructure as an example of where it can get, within a step, deploy infrastructure. Well, within that step, so we're gonna call Terraform to deploy resources in the cloud. But there are other things that we would call infrastructure setup. So one of the other things would be like deploying some of the base infrastructure services on the cluster.
Yeah.
So we would be deploying like, the Kafka software. We would be deploying, in a set of pods. So, Kafka, Scylla, various other different technologies that we would call infrastructure services.
Prometheus, yeah, so which is like the logging,
Elasticsearch,
the FluentD or the FluentBit and all that sort of stuff.
Exactly. So these are all sort of like the core infrastructure services must exist before we put any app services on there. So we treat that as part of the infrastructure setup. And so once we've called Terraform and the environment is there and the cluster is running, we then need to go in and say install the Kubernetes dashboard. We then need to go in and install the various different infrastructure services. Now, the infrastructure services that we deploy using Helm. So Helm is a package manager in effect for Kubernetes. So for packaging Kubernetes applications, which just really a bunch of related Kubernetes manifests, Kubernetes resources. And so Helm is a way of being able to package and deploy those to an environment. And so invoking Helm to deploy the various different infrastructure charts, we invoke through Piper within our DevOps container. So within our DevOps container, we make sure we have all the software available, including Piper. So Piper has a bunch of container images that are in Docker Hub, which can be used by anyone. And we have a sort of what we call a Piper Ops container, which contains a bunch of sort of the more popular DevOps type SDKs and so on, and applications. So we use Piper Ops to effectively not just run Piper pipelines, but to do Helm. So it's got a Helm install in there.
Yeah, and
Terraform, it's got a Terraform install in there.
And I think it's probably useful to point out, because I know we talked about Piper a lot, but it is open source. And if you search GitHub Piper, that's Pypyr, GitHub Piper, Google that, you should get taken to the Piper project in GitHub, and it's all open source, and you can just follow it, use it. It's free. It's all there. So all this stuff we're talking about with Piper, that's just out there. Go and use it.
Absolutely. So we use that for a lot of the sort of micro steps within the DevOps process. We've just mentioned Helm. Yeah. Helm is actually, so we don't just use pre-made Helm charts that are provided by the community, right? So there's like a Google repository or stable repository which contains a whole load of Helm charts. Various different companies have their own repositories, like Elastic has their own Helm repository to make Elastic and Kibana available as Helm charts. So there's a lot with companies that are building infrastructure services, they're making them work on Kubernetes. They're now more often than not supplying Helm charts to make it easier for people to deploy these infrastructure services.
And that's just like amazing. Yeah, it's just like when we talked about some of the things you just touched on there. We talked about some of it in the we did an episode recently on Kubernetes, and we did an episode recently on NoSQL. But it's just how much of this stuff you can, how much amazing things you can get for free. It's just like staggering. It's just absolutely
It is.
fantastic.
It's showing the maturity of the ecosystem
Yeah,
around Kubernetes. That we now have tools like this that we can use to make it much easier to be able to deploy and upgrade and manage environments and so on. We also use Helm really for our own application microservices as well
yeah.
to pack those resources up associated with those microservices. So we use Helm pretty much across the board. Naturally, we've talked about Docker.
Yeah, because
That's sort of,
Docker's a funny thing, isn't it? Because it's almost. I mean, I don't know how many years ago it was that I started looking at Docker, but like if you can go onto the Docker website and build your own container in and you can be off and running with your first container in like half an hour or something. But Docker's almost like become on its own. It's just something that we see now as being baked into everything else. It's become one of those underlying kind of platform technologies that everyone just assumes is there and don't really think about too much now.
yeah, it's funny, isn't it? Because have we got to a point where Docker is synonymous with containers? A bit like Hoover and vacuums.
I think
Docker.
we pretty much have.
It's. I mean, there are alternatives. You don't have to use Docker, and
Yeah,
Kubernetes can work with alternative container services. But yeah, I think most people really, if you think containers, you think Docker.
yeah,
I would say,
and other vacuum cleaners are available other than Hoover.
That's true.
And without going down the Dyson rabbit hole,
Yeah, yeah,
because they've almost become the default one now. But it's going to take a lot for containers. I don't know. It's just like containers, Docker. It seems to be synonymous. But interestingly, Docker have kind of lost the war for container orchestrators or container runtime.
yes, I think so. So container runtime, I think, yeah, it's Docker or Docker CE, which is the community edition, effectively the open source version. Because Docker obviously are a commercial company and they have pay for solutions.
I've got no idea whether they make any money or not, though. I don't know any. I've never met anyone that pays for anything that Docker have done.
Yeah, not me neither, but I mean, I guess they must do. They exist. So unless they got lots of VC money, I don't know.
I'm assuming they've got a lot of investor money.
I mean, it's a bit like Elastic, right? If they're a commercial company, then good luck to them.
Yeah, but I mean, I think Elastic have figured out where their monetization comes in.
Yeah, we could go.
But let's not go there right now.
I was going to say we could go off piste about commercial companies with open source cores, but reality is that they if we want to be able to use their software, then they've got to survive somehow. And I actually don't see a problem with. It's quite a nice model where you can use the software in development and test and performance environments and so on, without having to worry about licensing. But why would you want to run necessarily a production environment without some sort of support contract or some sort of safety net that you can get from the manufacturer?
And I think that's where certainly that's where Mongo do theirs, isn't it? It's like if you want a supported production installation, then that's what
and some of them have sort of like enterprise or pay for features, which and I think it's a perfectly good business model.
Yeah,
it's if you're running in production and you want that safety net and pay for it.
Yeah,
and help then contribute back to the ecosystem of making then the core available to everybody to use. It's I think
it's the same thing. if
Perfectly.
if you like music, buy the CD or buy the concert ticket. Otherwise, those bands aren't going to be around.
Exactly.
So
So,
it's the same thing in with bands of software products that you've got. Ultimately, if they don't find a way of making money out of it, they're going to disappear. And Docker's one that I'm kind of worried about because I think they'll be. I can't see I can't see how they can go on as they are without possibly being bought by someone and bought by
uh,
someone that has them as part of a way of making money. But I think that's probably a bit off topic there.
yeah, just slightly, yeah.
But we've covered. Okay,
I think we've covered quite a lot of the sort of technical platform.
yeah,
We've mentioned EKS, so Amazon's managed Kubernetes environment. So we've
yeah.
mentioned that quite a bit. I mean, we could have used Azure's, AKS. We could have used Google's GKE.
We could have built our own install of Kubernetes.
We could have done. Could have
But
gone on.
why would you do that? Because someone's already solved the problem.
Exactly. We could have gone on-prem, but I guess
But
we've got enough of an architectural abstraction between what we're doing and what we're running on.
yeah,
That means that we could make those choices.
I mean
Um,
that's again going back to the Kubernetes thing. The whole beauty of Kubernetes is that you've made that separation so that you could spin up a completely different way of hosting Kubernetes, and your applications wouldn't know.
exactly right. Yeah. So that's the key. Obviously, there's like infrastructure setup would be quite a bit different, but but fundamentally the application itself and even the DevOps process,
Yeah, it's
does
pretty much lift and shift then.
lift and shift. Yeah. Um, so the one thing that we haven't actually talked about is which is not necessarily directly related to making application changes and watching them go through all the way into various different environments. But a key part of all of this is how do you manage your tasks?
Yeah,
How do you manage what you're doing? How do you relate back?
yeah,
Uh,
because we started at the source control thing, but really, what you start on is a task, isn't it?
exactly, and
A piece of developer's work doesn't start at the point where they commit. That's the end of their piece of work.
exactly, and you want that traceability, right? So we talk about
Yeah,
Git as source of truth, um, but you also want to be able to relate the changes that you've been making to your source, uh, being able to relate that back to tasks that have been defined by somebody on a backlog. And we sort of briefly mentioned Jira, but we found that Jira wanted to force us down a fairly rigid route of Scrum.
yeah, they're quite opinionated about how you do your process, and
Exactly, and
it's like
we,
how long would you like your sprint to be? Is basically how much flexibility you get with Jira. That's a little bit. That's probably a little bit unfair to them.
probably a little bit unfair, but it
But
didn't
the
really
thing is,
work
if
well.
out of the box, that's pretty much it's not too far off the mark, and then you can customize Jira, but then you kind of into that whole thing of is that effort worth it?
Yeah, and for me personally, I found it's a bit like CRM, where you can end up with like endless tinkering of the application to get it to do what you want. But then if you then upgrade the you upgrade the version of CRM underneath, it's like, oh my god, you got to,
I've lost all that. I've got yeah,
or it's like how do we migrate it?
yeah.
But no, it's just that it's just such a myriad of customizability that it was just we do it's too much effort to think about. We've got more important things to worry about in terms of making sure that we are developing our service than to be worrying about customizing our task management tool.
Yeah,
So,
I mean the thing with ClickUp is that, I mean, we just talk a little bit about some of the really good things about ClickUp, but from where I look at it, it's it's the fact that it's almost natural. It's naturally flexible in that you can kind of get to use it how you want to without feeling like you're fighting it. Um, it just sort of naturally kind of seems to want to work in a way that seems intuitive.
Yeah, so so we hadn't actually introduced ClickUp at all. So yes, we use ClickUp,
Yeah,
and it's exactly for that reason that it isn't opinionated. That we can build our process exactly how we do our process. We can build that around ClickUp. So there are a couple of weak areas that ClickUp has, which is really around. So we are agile based. We don't really operate Scrum though. And we're probably much more sort of Kanban based, but we have our own specific flavor of agile. We're trying to be as lean
yeah.
as possible, yeah, as low overhead as possible on the whole process.
I mean, when I look at the way we run it, I see it being more like Kanban in that I mean, we have, you know, there's the whole thing of sprints or iterations or whatever. So we do have some kind of control and iterations, but really that's an iteration doesn't have to, work doesn't have to stop to finish an iteration, but it's really just you get Kanban and then within that you pick things off, but then
It's buckets of
it's
work that you
buckets of
can
work.
say, yes, exactly. So we call them waypoints, but they're basically groupings of tasks that sort of have a goal, an
Yeah.
overall goal. So a bit like a sprint goal.
And really the thing with us with the Kanban is that within a waypoint you've got a whole bunch of tasks and you can Kanban those off, but you shouldn't start on tasks from the next waypoint until you finish those ones. So it's a bit like
But if
a
you're
bit of
the last
FIFO, isn't it?
person, it is. But if you're the last person working on the previous waypoint,
Yeah, then you can start picking. Then
but
that
the
that
whole team doesn't stop waiting and watching
the
you
whole
as a
team doesn't
person.
stop waiting.
They can pick up the next
As
waypoint
soon
task.
as the last task from the previous waypoint has been put to in progress, then it's fair game for the rest of the team to pick up the new set of tasks.
Yeah, well, yeah, we literally just do not.
Yeah, we don't stop.
We don't stop. So we don't say, right, okay, last person's working on their task can take them a couple of days. No one else can start new tasks until we're finished. It's like people just keep going and going and going.
And that's one of the. I think that's one of the
Like Paul Canva
That's
style.
but that's one of the weak points of Scrum, isn't it? I think you end up with that kind of at the end of if you at the end of a sprint, you do end up with like someone's finishing something off and everyone else is twiddling their thumbs waiting for them to finish so that they can ship a.
Exactly, and I think sort of the time boxing work into a period like 2 weeks. It's one of those things where you start the sprint and everybody's sort of, oh yeah, we've got loads of time yet, right? So it's sort of bumble along, and all of a sudden, as you get towards the end of the sprint, it's like, oh right, okay, now we're running out of time, and then the workload goes up, and so you never have this sort of even flow of, or not that I've ever seen anyway, where you get this even flow of work output across a sprint.
Yeah.
There's peaks and troughs. Whereas actually, if you just take a more Kanban style approach where it's just tasks on a backlog and you just keep churning through them, you get this sort of natural flow. There's no artificial end to something where everybody panics to get to meet that deadline.
Again, we're probably getting a little bit off the DevOps thing here.
We probably are actually,
but for me, I think that Scrum. I mean, when Scrum first came about, they were recommending like 4-week or 1-month iterations, and I think that was probably if you'd been doing waterfall, going to monthly iterations on Scrum was probably the first bit of agile you could swallow. But it definitely not the place to finish. It's probably the first step into agile was to effectively you made a 1-month waterfall, and then you can start to compress that down. But the more you compress it down, like you say, it doesn't really work. But it's probably that Scrum was probably the first. I say that if you'd been doing completely waterfall projects and you wanted to go agile, Scrum was probably the first port of call where you could actually come up with a sensible kind of first agile process.
But, yeah. I mean, we are it's slightly off beam, but I think it sort of
Always
feeds.
off beam.
Yeah, well, that's true actually. But I think it feeds into the reason why we use ClickUp because our process isn't strict. Um, we can't really use find it difficult to use a strict tool.
Yeah.
And so ClickUp is really nice in that respect. As I say, though, there are some downsides in that it's not specifically an agile tool. And so some of the nice things that you do get out of a more strict agile tool, things like burn down rate, burn down charts, being able to measure, to get the tool to measure velocity and so on. We have to do that manually. So there are, the nice thing about ClickUp is it is continually being improved. It's continually being worked on, and there are some features, I guess, on their backlog that they've been talking about that will introduce some agile type capabilities into the tool. But at the moment, we have to basically manually measure our velocity.
Yeah. And that is, I suppose that's probably the most painful part of it.
Yeah.
Because and I don't know, but any kind of once you go to a continuous delivery model, and of literally ship any time, then a lot of burn down velocity is still important, but burn down becomes irrelevant anyway, I think, because you
don't have fixed iterations, so there is no sort of burn down to like all points are harvested this week, or within that period. But velocity is important.
Yeah.
And because we don't have fixed task sizes, so if you were like doing maybe Kanban, you might have, so you measure the rate of closed tasks in a week.
Yeah, but you have to.
But you have to make sure that they're sort of roughly the same size, otherwise it doesn't really mean anything.
Yeah, because you can't have like one week you do 5 one-day tasks, the next week you do one week task, and then Kanban says, "Oh, you've only done one task this week."
Yeah, it doesn't really sort of. So we in order to you end up expending more effort in trying to make sure that tasks are broken down to a point where they're all roughly the same size, that you've introduced overhead and waste into the process.
Yeah.
Into the process, and so if you want to be somewhat flexible in that regard, then we still use. The idea of points, but we don't actually use specific points. We use more the t-shirt sizes, right? So we call a task weight, but it's overall rough size of a task, and so we give that behind the scenes. We give that a number.
Yeah,
we can use that in a velocity calculation.
And that's the whole.
A bit of a combination of.
But effectively, the t-shirt sizes, because the way we do it, and again, we probably need to do an episode on this.
Probably do actually.
But you've got the from like the small, medium, large, extra large, XXL, all those ones, and then they map onto like the Fibonacci, so that so as they go up, they get progressively much more weighted, and because
the bigger the task, the more unknown it is. Therefore, the more likely you're going to have that.
Yeah.
You've got that unknown factor into it.
Yeah, and typically, I think this is something we've both found through experience, that when something is longer than a week, that if it's less than a week, you've probably got a reasonable handle on it, and if it's longer than a week, you'll probably you start to get that uncertainty, and But at the same time, and I think this comes back to the Kanban thing, in that ultimately, there are some features that have to be delivered as a thing, and some of them will be really small, and some of them can be a lot of effort. But there's no point, if you're doing a continuous delivery model, then you have to at least finish a feature. So all that happens with Kanban then is that you've got a feature, but you've created a whole load of subtasks for it that are roughly the same size, but like I say, you're still ultimately delivering that feature. Yeah,
and so certain task sizes, task weights do need breaking down, right? Because they're too big to be given to someone to say, just go and do this, because they won't have enough definition. So to think about that definition, actually, what does this task mean? naturally will mean you start to break it down into smaller things. But I think that the problem comes when you're trying to say break a, I don't know, a 3-day task down into 1 days, because your task size to try and get it uniform are all 1-day tasks.
Yeah.
There's just more effort on the part of someone having to do that breakdown.
Yeah.
When actually, you know what, maybe the 3-day task is still good enough for somebody to work on, and why break it? Why waste that effort breaking it down even more when
It is, and then you've got the kind of the duplication, the definition of done stuff, and
yeah,
it's just so. I think
it's taking that lean approach of
lean approach.
eliminating waste in the process, and for me, part of that is the way that tasks are broken down and contribute towards waste. If you're trying to go to the nth degree with it.
Yeah. So I think we've pretty much covered off the top level tool stack, haven't we? But what we haven't really talked about much are maybe some of the. I mean, there's a little bit about what does a dev workstation look like? Because obviously that's where the stuff happens.
Yeah.
And other tools and other technologies that we're kind of going with, which kind of inform some of the choices we've got to make on the DevOps. Should we quickly have a look at some of those?
Yeah. I mean, we don't need to spend too much time, but so from a workstation perspective, obviously we're running Linux containers on Kubernetes. So anything that allows you to develop in a more sort of Linuxy or POSIXy way.
Yeah.
So in terms of your workstation, so most of our devs really use Macs. I don't. I use Arch Linux.
But you use that as a VM, don't you? So
I do.
So Windows machine, Linux VM.
I run a Windows desktop or host machine, but I use virtual machines for development, and so I have an Arch Linux virtual machine which I do dev in.
Yeah.
Doesn't mean they're not ever going to have a Mac. I mean, it's on the roadmap for me.
Yeah.
But Mac at some point. But yeah, I really like Arch Linux, and so the good thing about actually having a couple of slightly different environments is it keeps the implementation honest, because
you realize you can't get away with if you inadvertently find something that is specific to that flavor of Linux or that flavor of Bash or something like that, then it gets found out.
It gets found out. So exactly that. And so although we don't necessarily say that you must use this operating system, something POSIXy.
Yeah, I mean, not that I delve into code much these days, but I'm a bit lazy, so I just go for a Kubuntu.
Yeah,
it's all there, and that makes some things slightly different because you've got different installers from Arch. But something POSIXy.
You just need to be able to run Git, which is almost certainly going to be okay. But you need to be able to run Docker and Kubernetes.
Yeah.
So there are some requirements on whatever it is that you choose. You just got to be able to run these tools on top.
Yeah. Go on.
So we don't, again. So with an IDE, the development environment for writing code, we don't tell people what they should use. I personally use Visual Studio Code, which is just amazing, really. What it gives you, is fantastic as an environment.
Do any of our guys use anything different?
Yeah, so some of our guys use on the Mac when they're developing Golang services, they use Goland.
Okay.
I use VS Code. It is fantastic, and I think a lot of the. So you could just use a text editor, right? But
Yeah, but
The benefit that you get from having an IDE with um, a lot of features like debugging and automatic test running and code coverage results, and all of these sorts of really good thing, IntelliSense, um, all these things that just make your life much easier as a developer is, I think is essential, really.
yeah, because
You've
when
got to
we
get productivity, any sort of velocity out of
because
out of,
when yeah because when 345 first moved over from because we used to be kind of a Microsoft house, and then we moved to being more of an open source Linuxy house. And the first the first thing that was around about the time Visual Studio Code first came out, and at that time we were using Atom a lot because you could get a lot of plugins for it and language plugins and linting plugins and all that sort of thing. And Visual Studio Code was a bit immature, and and for me, I found it quite a difficult time because, like I say, because we've been used to the the full fat Visual Studio, which gave you a whole lot, which you know, much as some people may hate it and some people love it, but it actually gave you as a developer a whole load of really good stuff. The refactoring tools, the finding a symbol, the IntelliSense. There's actually a lot of good stuff in there, and then coming away from that, and I think Visual Studio Code is gradually kind of getting there with all that, isn't it?
it is. I mean, it isn't. It's nowhere near full fat Visual Studio at the moment. But to be honest, you don't really necessarily want it to be, because the thing is, it's still quite lean and mean. And the more stuff that gets added in, the more unstable it's going to get, and the slower it's going to get, and so on. The one big thing, I mean, it does have debugging, but debugging on full fat Visual Studio is pretty good. With all of the
Yeah,
thread debugging and so on. It's
yeah, monitoring your variables and
pretty extensive, and
yeah,
it's a little bit more basic on Visual Studio Code. But saying that, it's still really, really good as a free development environment. It's fantastic. But as I say, we don't tell people what they should use. The only time that we would maybe question what people are doing is if they're not gaining from the productivity of having a rich development environment.
yeah. But
Things like
if they're if
the IntelliSense, the debugging, the code coverage. If they're taking longer because they're simply not using the right tools, then we might have to.
yeah,
You know,
if they've taken it upon themselves to use Vi as their development environment,
yeah. Then it'd
then
be like, really, come on,
sort yourself out.
Yeah, yeah. Because I mean, at the end of the day, we need to maintain a certain velocity, right?
Yeah,
Because commercially, we can't just spend all of our time writing code. We've actually got to deliver something. So it makes sense to have an environment that makes the development experience richer and therefore more productive. So, but as I say, we don't at the moment we don't tell people what they should be using, but we do keep an eye on it.
yeah,
Um, we use Slack for internal communication between the team, but we also use Slack for the sort of the chat ops area. So we use Slack for a lot of notifications from things like GitHub, GitHub for commits and PRs and review comments and things like that. We use Slack for shippable notifications on when builds have succeeded and failed. We haven't yet enabled Spinnaker integration with Slack, but we can, it's actually on the backlog, interestingly. So, but yeah, we can hook Spinnaker and the way when it runs its pipelines and so on. We can hook that into Slack. Task management's all hooked into Slack as well. So when tasks are assigned to people, when they change status and so on, that all of the notifications for that are pushed out to Slack. But also we have other things so we can hook into Amazon's on the AWS side when they are raising any security notifications like CVE patches. then we hook into that via Slack so we can see when Amazon have made a patch to an EKS image that we need to roll out. So, and also new versions of Golang. Piper, we also have Piper hooked into to give us notifications through our Slack channel as well. So we use Slack quite a bit, not just for chatting, but for a lot of notifications from the environment. We could, we haven't yet, but the whole area of alerting from the perspective of alerting when, I don't know, the nodes in a cluster are above a threshold, go, from a CPU perspective, go above a threshold.
Yeah.
Then we can alert through to Slack in that respect as well, and other places obviously. But so we use sort of Slack as very much in that chat ops vein of collecting all of this information that's going on, not just for us to have team communication, but for lots of other things too, which is really good. Although it can become quite noisy, but we have separate channels. So we don't have everything going into one channel. We have very specific channels for certain things. So
and then make sure the right people on the right
go
channel.
Into one channel, Git goes into a different channel, and security notifications go into a different channel again. So people that are interested in, that are joined to the channel but are not necessarily interested in those notifications can mute the notifications so they don't go crazy, right? But yeah, generally speaking, we have a whole range of channels for which we have a lot of these automatic notifications. We tend to keep our team communication channels separate. So notification channels we don't tend to chat in, generally speaking. There's nothing to stop you from doing so, but we don't generally chat in notification channels, and we tend to have separate channels for that. And the other thing we do as well, just to sort of close this one off, really, is although we have a morning call with the dev team.
Yeah, so we do daily huddle.
We do the daily huddle. We also use a tool called Stand Up Leave for allowing people to do what we call debrief, which is like an async stand up, but people can put a bit more detail into their sort of daily debrief into Stand Up Leave through Slack, which is integrated through Slack. And so at the end of their working day, which I always find it's easier to do at the end of the working day rather than the next morning. When you finish the day, this is what I've done, this is what I'm planning on doing tomorrow, put that into your debrief. People can read it offline and then just have the call to, in the morning to sort of catch up and get the team communicating and get to see everyone's face in the morning, just to say hi and see how everybody's getting on. So it's an opportunity to collaborate, but combined, they sort of work quite well together. So
Great
that
stuff.
I think pretty much
that really much sums up our stack.
Sums up our stack, yeah.
So that was amazing, amazing stuff. What seems to fall out of this next really is we've talked about the tool stack. So what we'll go into the next episode is I think we're going to talk about how we use those in a bit more detail, because there are now we've got the tool stack, then we need to look at how a bit more. We'll go into a bit more detail next time on how those things actually hook together to make a process that is a working DevOps process, because that's ultimately what where all the goodness is, isn't it? It's how those things all work together. So
yeah,
that's what we are.
So from the point of commit through to that change appearing in an environment is, how does that actually really work in practice?
Yeah. So that's where we're going to head next. So I think we can wrap up there. Thanks to everyone for listening. We love all our listeners. Thank you very much. We've really excited that we Um, I mean, we're going to be in four figures soon for the podcast, so that's just like amazing stuff. Really, we do really appreciate the fact that you listen to us. And when we look at the analytics on it, it blows our mind that there's like people on like Air Force bases in Utah that are that are downloading the podcast. Really, yeah, it's amazing stuff. So thanks a lot for everyone for listening, and hope you've enjoyed this one. And we will be back next week with more amazing tech talks on the subject of software development and pushing out amazing technology. So thanks a lot, and we will catch you next time.